Pleased to be here from Sydney, Australia. I'm going to start with a slight apology. I haven't got very many tall buildings to talk about, actually, in terms of refurbishment, partly because there aren't many great examples of it. It's not really an area where anyone's been yet terribly much. So this is more about the possibility for us as design professionals and building owners of the future. So there are some case studies. I'd like you to just use your imagination a little bit and think tall when you see some of the case studies that maybe aren't quite so. So these skylines, they're our heritage. They define our cityscapes. There's a colossal amount of value, dollars, locked up in the real estate in these cities. Now, a lot of the real estate in these cities is aging quite quickly. A lot of it's becoming obsolete. Arguably, some already is obsolete based on what some of our tenants are doing. There's a huge amount of locked-in value, locked-in carbon, locked-in energy. We probably can't afford in the future to be throwing that away. And also, is it really conceivable that we're going to be knocking down buildings like the Empire State Building because it's obsolete? Well, maybe it is. I doubt it somehow. So the question is, how do you stop it from becoming obsolete? We were approached by the World Economic Forum to go around the world and talk to building owners and design professionals about what was happening in the retrofit market and what were the barriers to making things happen a bit more quickly in the retrofit market. We talked to people in America, China, Japan, Australia, the UK, Germany. Japan, if I haven't already said that. So the major real estate hubs, if you like, the developed real estate hubs. And what came out of it are things or numbers you've probably seen similar before. You know, buildings use a massive amount of resource. 40% of the world's energy, 40% of the world's carbon footprint, fifth of the world's available water. Interestingly, 50% of today's existing building stock is still going to be there in 2050. I'd like to think it's a lot more than that, actually. I'd like to think it's more like 80% minimum. The available energy savings within this building stock are estimated at 20 to 40%. I think it's more like 60% plus, actually, for the future, and probably even more than that. There's loads of green jobs, up to 1 billion green jobs to be created, perhaps, in the US alone, in the green economy in retrofitting buildings. Big numbers, big statistics when it comes to savings in energy, savings in greenhouse gas emissions. So that's the context. The key observations from that study: retrofit markets for commercial buildings are in their infancy. Sort of suggests why this isn't a full room, perhaps, with indicators of growing demand. Building owners rarely make retrofitting a priority unless government makes it a priority, and business see it as a clear return on investment. Point was made earlier this morning in this room about getting involved with the political cycle. There's no doubt the countries where the politicians have grasped it as an issue and are starting to legislate for improved improved building carbon performance. They're already making big steps in terms of improving the performance of building stock. Obvious things like retrofits happening at the time of asset repositioning, and again the government holding the power to spark catalysts. It was seen, actually, the thought was that finance wasn't available for these sorts of projects. Actually, the study found that it was, as long as it made clear financial sense. So the Property Council of Australia came to us as well a few years back and said, well, we get the idea that existing buildings are a big issue. Tell us what's going on around the world. So we networked our offices, and we found out, roughly what was going on around the world, what are the trends, and came up with these survival strategies. We talked to tenants and said, well, what do tenants want? And it's the same old, actually. More effective air conditioning, environmentally friendly ratings, better lifts, flexible lease terms. It's the same thing. Nothing really has changed, actually, in what those tenants think they're waiting for. Quite nice, actually. The big bar at the bottom, 33%, is no change. So it means at least a third of people are pretty happy, I guess. What are the real tenant trends coming forwards, though, do you think? We're seeing increasing population densities in buildings. We're seeing a move to activity-based working where tenants are sweating their asset. We're seeing a much greater demand for healthy environments, health and well-being of staff to attract and maintain the talent of Generation Y. And new things for the future: maybe hyper-connectivity, looking after an aging workforce perhaps. Lots of things. These are what we think is coming in terms of tenant trends, but most of all, I think, better design. So this is what the existing stock sort of got to compete with. In my hometown in Sydney, this building, it's got the works, it's fully blinged. A really efficient facade, solar cooling, natural ventilation, chill beam air conditioning system, tri-generation heating, cooling plant. It's got everything. So the existing building stock has got to compete with that. Now, can it do that? Probably can, actually. If you look at the buildings through the ages, 60s through the 2000s, sorry, you probably can't read that very clearly, but every generation of building had a typology. If you think back to the 60s and 70s, the air conditioning was pretty rudimentary. If it was noisy and drafty, it meant it was working, so that's probably a good thing. We've moved on a bit since then. The idea of a much better environmental control from our air conditioning systems is what tenants expect, and they've got a right to expect that. Those buildings in the 60s, 70s, and 80s, they weren't designed for IT. They weren't designed for desktop computers. They weren't designed for the power loads that came with that. And most of those buildings actually already been retrofitted to cope with them, because otherwise they would have been made obsolete, or they've already been knocked down. And it's these types of issues. Actually, think, well, if you look at the trends of the new buildings, how do we evolve the old buildings, the old technologies into the new buildings so they can perform as well as or better than the current generation? So to our mind, it's a balance about sustainability, tenant need and want, and the owner's benefit as well. It's a nice little triangle there, but the balance has to be really well made. If it's weighted towards too far towards one side, it will tend to put off or just devalue part of the other side of the argument. So that strategic improvement plan, that booklet suggests, there's 100-odd different possible initiatives within that, from the fairly banal, such as improving light switch labelling and talking to your tenants about how to operate and run and inhabit a building a little bit better, to the far-reaching, such as renewable energy, retrofitting, wind towers and stuff that's a little bit more out there. So we've got a few case studies now that really sort of move through some of the potential for existing buildings. And again, imagine this is a tall building, a really tall building, because the same principles apply. It's a 30,000 square metre sort of A-grade office building in a CBD environment, 20 years old, constructed quite well, looked after quite well by a reputable owner. And they came to us and said, we'd like to improve the sustainability performance, particularly around energy and occupant comfort. So with our latest tools, we're actually able to remodel the potential performance of this building far better than they would have been able to do 25 years ago when this building was being designed. We could actually determine what the real potential of the building should be against what it was currently operating at, and go about trying to work out the most effective, most cost-effective way of getting that performance out of a building. So we re-engineered the systems using slightly more efficient equipment and design techniques. We replaced the control system. We re-engineered the control logic, so it was modern and effective. And most importantly, we actually retro-commissioned the building. So we didn't really do that much internally. We replaced the chillers because they were knackered. And thereafter, we actually just recommissioned the building, probably the first time it ever really been properly commissioned. Probably wasn't done properly ever in the first place. We fixed the bits that were broken. There were quite a few of them when we went looking for them. And the results were, what you see there on the top left is the slight salmon pink bar charts for the energy or monthly emissions for this building for the year 2010-11. The red dotted line was and the green dotted line, that's what we were hoping to achieve in operation after the strategic improvement upgrade. And the blue is actually what we have achieved. So just a little bit of tweaking, a little bit of fine-tuning, a bit of retro-commissioning and some new chillers, and we've pretty much halved the emissions of that 80s building. And then that's great from an outgoing cost and sustainability rating point of view, if you like, but the key outcome is actually the occupant comfort index, which we're now monitoring through our new control system, is through the roof. the tenants are really happy, and if they're not happy, we know about it and we can do something about it. So not only have we got carbon performance equivalent to a new build, we've also got a much happier tenant. So there's another one, a pretty average building. Architectural, I'd say. Probably never an award winner, but you never know. I hope the architect's not here. Centre core, about a 1,200 square metre floor plate. The tenants in this city are calling out for campus-style big floor plates, column-free, campus-style developments. There's nothing really available in the CBD, and no sites available to build them. So Stockland's, this organisation, turned this into their headquarters and said, well, how do we create a campus environment for our staff in that type of building? Well, the answer here was actually just to cut a 10-storey atrium at the side of the building, interconnect all the floor plates to get that campus feel in a vertical village type of environment, which was done quite effectively. Now, what's so clever about that? Well, actually, it's totally against all the fire codes. So with a bit of advanced fire engineering, you can just about see them here. You've got some little wires coming across here. In the event of a fire, we've got smoke curtains that zip out across to create smoke compartments, makes it fire compliant, and Bob's your uncle. Great space in a pretty average building. It's really increased the asset value of that property for that owner. So this is another one. Handsome old sandstone building. Now this was a high-rise in its day. Quite a few stories above what's surrounding it. There's no way that's ever going to get knocked down. It's part of this city's heritage. This was the original floor plate. This building was designed at a time when they really understood passive design techniques, because they didn't have air conditioning, they didn't have electric lights. So it's designed for natural ventilation, it's designed for natural daylight. And over the years, bits of those light wells have been filled in and seen numerous iterations of technology applied to it, and it had basically become this, which is a pretty grim, dark, soulless space. Probably fine for the insurance agents that work there, but I wouldn't want it to work there. So the insurance agents moved out and the building was bought, and the client said, we need to do something about this. And, this was what was above that ceiling. It was a building services engineer's dream, really, looking up there. All that space with not much going on. What a waste of opportunity. And a fantastic example of structure services integration here. Big duct under big beam. Makes your heart warm. So plenty of potential there. The idea was, well, let's create a new heart for this building. Let's cut a heart into the building, new vertical circulation route on plan, as you see there. If you look at the old plan against the new plan, it's more or less the same floor area, albeit displaced. So the existing light wells here and here have been filled in, a far corner, and a new atrium put in its place. Cut through the heart of the building, some extra accommodation and plant rooms up here on the far right there. So that means a lot of structural intervention. And given new codes, new standards and new analytical techniques, we were able to post-analyse this old building, work out what was safe to take out, where things needed to be reinforced, and in came the diggers and the saws, and away went the old concrete. So pretty big cuts, creating this large atrium space, and that's it at the end. I mean, that could be a brand new building somewhere, couldn't it? That could be a glory shot of a brand new building. And here you see at the top, from the lift lobby, looking back across what is the old mansard roof of that heritage front elevation. And then looking down through that atrium. A great space. These windows here open up onto this atrium, so it can be naturally ventilated from the roof down. And also there's the potential, again, same issues with fire and smoke control with horizontal fire curtains. Structural engineers had some fun with some big bits of steel at the top, to create this atrium roof space. And what you see at the back here is effectively where all the plant was sitting. It just elevated towards the real elevation where nobody could really see it. And then finally, some of the old heritage components, saved, if you like, and encapsulated within the new envelope at the very top of the building. From a building services point of view, it was naturally ventilated. Couldn't be naturally ventilated anymore because of the noise and pollution of the city. We ripped out the old sort of VAV system that was sort of like chugging a whole load of space. And we thought, what's the most effective way of providing air conditioning to a heritage building such as this? And we thought, well, actually, let's put it all in the floor and expose the ceiling and get as much volume into that space as we possibly can. An underfloor air conditioning system went in that had a floor void height, the same height as 2 typical steps in the lobby. And there you have it in its finished result. Really simple, minimalist almost approach. You know, the air's coming out the grills, everything's happening in the floor. The old ceiling is exposed. A nice, elegant, simple lighting solution. It's done. So, you know, some things we did as we went through that, you know, there's a lot of material in that building that got stripped out. We recycled as much of that as we could. We actually sold a lot of it. We had an auction to sell off the old desks and other materials that were left behind. We managed very carefully the waste management strip out. And then we've added cyclicity, and we created this sort of different campus-style environment within this building. And then the technology bit, if you like. So we've got a new aircon system. We've also got a gas engine there for peak load lopping the power, partly because the local authority wouldn't increase the power generation or supply to the site. We've got, we had an big old sprinkler type tank in the existing roof. We kept that and we filled it with chilled water to use as peak load lopping. We put state-of-the-art air conditioning equipment in as well. So effectively, that building now as it stands there, you know, there's no way that you'd ever be able to afford to build a sandstone load-bearing facade like that in today's economy, I would say. But that building performs equal to or better than a brand new building, technically and socially. It's there for the future. You know, it's ready to start its next life. So this is a tall one. Owned by the GPT group, 60-odd floors. Harry Seidler was the architect, arguably Australia's finest architect. They said, well, we've got a lot of tenants moving out of this building. It's 30 years old. We need to demonstrate how this can be real-lifed internally. We can't afford to reclad it. We're not going to reservice it. It works quite well. What can we do? And again, this is what it looked like inside. It's pretty bland. We've seen there's a lot of space, probably billions of square meters of space like this kicking around the world. And this is what it became. Bespoke lighting system, an activity-based working system for this group. So nobody gets a desk. You rock up every morning, you pick up your laptop and your phone from your locker, you go and work wherever you want to work. And we're seeing a lot of that coming into our marketplace now. Saves tenants a lot of space because they actually don't need to rent as much because half their workforce never turn up. They're always out doing something else. So, you know, that's pretty normal, nice bespoke lighting system. But also, the air conditioning system was tweaked. And we're seeing generally a number of projects now where chilled beams are being added to deal with facade load in place of all air systems because they're small and they're efficient and they're full fresh air, so you get better environmental conditions as a result. In this particular area, they expose those services to add a little bit of volume and a little bit of design, if you like, to the environment. So, you know, and then the interconnected stairs. Only 2 floors. Just to get that community sort of feel going. So, you know, again, big building, fairly traditional, dated in many ways, but actually performing in a workplace context as well as any new building of a centre core type. So, lastly, another building, a building built in the 70s for a banking organisation. Pretty solid and unspectacular, well looked after, but in need of a little bit of a refurb. Now, a private individual bought this building and just fancied having a go at changing it. So some of the things that were done arguably weren't commercially that sensible, but the outcome has been exceptionally good commercially for this particular individual. The brief was maximise the potential of this building. It was as simple as that. And we did that by actually thinking, well, there's plenty of potential at the top of this building. That's where the highest value space is. It's not bad outlook at the top. Let's put some more space there. That's where all the air conditioning plant is. Well, that has to move then, doesn't it? What about the facade? It's not a great building. It hasn't got a great image. Let's get rid of that. And whilst we're going to get rid of the facade, let's extend the floor plate, get some more NLA on those plates. And then all the real value was at the retail frontage. On quite high value dollars per square metre. It was totally underdone as a banking chamber. So let's create 2 big volumes of retail space, one below ground, one above ground, because we think the retailers will go for it. We were able to post-analyse the existing structure with the additional loading on top, with the additional floors, with the big chunks cut out the middle of it. And what we found, actually, we needed to stiffen the core, we needed to stiffen the structure and do some other things. So how do you do that in the most sort of sensitive way? The facade came off. The core got stiffened with a bit of extra reinforcement and steel work. The floors got extended. Actually, it looks quite simple when you look at it like that. So that's an extra little bit of strip of area all the way around the building, all added up to a few extra dollars of income. We took the top off the building, cleaned it up a little bit, added some lightweight floors, 3 floors, which became really nice executive space. The retail unit, a big volume was created with some interesting space. In the lower ground floors, we carbon fibre wrapped the structure just to stiffen it up and strengthen it, rather than doing anything that was too chunky. We got the torches out and we cut the guts out of the basement to create another shell for retail. And then we reclad it. Dura limestone, quite elegant, deep reveals, not nicely designed. Spent a little bit of money there to give the building a bit of a brand. A little bit less money on the east facade, or the glassy facade, but so it's a different prospect. It's a totally real life. Could be a new building. And Apple liked it so much they came along and took the whole of the retail unit at premium rents. So again, you've got a real life building with a fantastic global brand in there, and which actually helped rent out the space above it. So as good as new, ready for the next 30 years, I think. So here's a load of buildings you've seen, not super high. In my mind, retrofit isn't generally considered to be terribly sexy. As an engineer, I quite like getting into buildings and poking around. You actually deal with them. You're not dealing with lines on a computer screen or even on a drawing. You're actually dealing with tangible components. And with our new technologies, with our new skills as engineers and architects, we should be able to really do something special with the existing stock. So in my mind, retrofit is pretty sexy, and I reckon it's possibly the new frontier, design and innovation and performance. Thank you.